we're going to make in section 7.3. It's talking about the sum and difference identities. Well, the first identity we're going to talk about is talking about cosine. So we're going to look at cosine. And cosine is cosine of a sum of two angles. And you can find the proof for this on page 645 if you want to really look into it. It's looking at, I have one angle here, say B, and then I have another angle that opens up, say right here, that's angle A, and then A plus B or A minus B. A plus B might end up somewhere down here. This angle from all the way over here to here is A plus B. And so how do you find cosine of that? So A plus B, and then A minus B might be something like right here from purple to here is A minus B. And so find cosine of that. So you can find the proof on, use different types of identities and some algebra there, Pythagorean theorem and stuff like that in order to find these formulas. But the cosine of A plus B, meaning two angles, when I add two angles together and taking the cosine of that, it's going to be cosine of the first angle times cosine of the second angle minus, so I'm going to switch my signs here, times sine of the first angle times cosine, or sine again, of the second angle. So cosine of the first times cosine, so this is times cosine of the second, and then subtract. I always do the opposite sign. Cosine is the opposite sign. And then sine of the first angle times sine of the second angle. And so I told you the story about Sinbad and Cosette and their dates that they had to go on. And Cosette, when she arranges the date, she goes, hangs out with her sister during the date, so she doesn't hang out with Sinbad, and she makes Sinbad hang out with his brother. So we have O, and then Sinbad, right? Sine, Sinbad, cosine, Cosette, and then so that's how you can remember it. Cosette arranges the date. She hangs out with her sister because they're on a double date, but she thinks their signs are different, so they're not destined for each other, so their signs are different. Whereas Sinbad, and I'll explain that when I do sine. So cosine is cosine of the first angle times cosine of the second angle, and then you always change the sign. And then you take sine of the first angle times sine of the second angle. And then for the difference, so cosine of A minus B is cosine of the first times cosine of the second. And I switch the sign. And then Sinbad hangs out with his brother, so Sinbad, sine of the first times sine of the second angle. Okay, so that's the sine and cosine, the sum and difference identities for cosine. So let's go ahead and do some examples. Okay, so here's the example. We're finding the exact value, so basically it means like no calculator. So you can use the left-hand method and 5. In your palm, everything goes over root on top and then always divided by 2. This is 0, this is 30, this is 45, this is 60, and this is 90. And then you can do the same things with the other angles. You just got to take, is it positive or is it negative? Well, and so why we do these sum and difference formulas is because we have angles like cosine of 15 that we don't know. We know these ones, 0, 30, 45, 60, 90, but we don't know 15. So there's a way that you can do it without a calculator. That's what you'll be asked to do on the test. You'll find the exact value. So cosine of 15 is the same as cosine of 60 minus 45. 60 minus 45 is 15, right? So cosine of 15 is the same as cosine of 60 minus 45. So then I'm going to use my formula that says Cosette arranges the date. She takes Cosette, cosine of the first angle. She hangs out with her sister because she doesn't like Sinbad. So hanging out with the sister, so another cosine of the second angle, and then she thinks their signs are different, so to a negative subtraction to a plus in the middle, and then she makes Sinbad sine of the first, hang out with his brother sine of the second, 45. Okay, so then we can do the left-hand method here, or we can use our chart, cosine of 60, put this finger down, it's to the left, that's 1, square root of 1 over 2, so that's 1/2. So that means sine would be to the right, so 3 fingers are up to the right, so square root 3 over 2, so sine of 60 with 3 root over 2. So you're seeing always going to have this with both sine and cosine, the sum and difference formulas. Basically, whatever your angle is, you're finding the cosine and sine of that, so really you're finding the coordinates of that angle. And same thing with cosine of 45. We can drop down this, we get 2 to the left sticking out, 2 right here, and then 2 to the right, which is sine, so square root of 2 over 2, and the same as cosine of 45, square root of 2 over 2. Now we're multiplying in between here. And remember, you just found cosine of 60, so you don't need to write a cosine here. Don't do that. Don't write a cosine here. It's now gone. Cosine and sine are now gone. So now we can multiply these, we get root 2 over 4, and we're adding in the middle. And here, root 3 times root 2 is root 6 over 4. Why did I put a 2? Over 4. And here we can add these fractions because we have common denominators, 4 and 4. So it's all over 4. Can we add root 2 and root 6? No. So we get square root 2 plus square root 6. Because they're different. They're both square roots, but underneath the radicand, what's underneath the square root is not the same, so you can't add them. So our answer of cosine of 15 is equal to this. Okay, another one. Here we're in radians, so we could try to rewrite cosine of 5 pi 12ths as something as cosine of some fraction plus another fraction. That equals, so these two fractions would have to add up to 5 pi 12ths in a way that we know, because we know pi 6ths, we know pi thirds, we know pi fourths, we know pi halves, right? Right, and we know 0 pi. So we know, 30, 60, 45, and 90. So we know those ones. So sometimes it might be best to take this and convert it to degrees. So multiply by 180 over pi. So then the pi's would cancel out, right? And then 12 and 18, that's going to reduce down to 12 into that 1. 15. So then we get 75, so 75 degrees. So really we're looking at cosine of 75 degrees. So that's an easy way to do it. Then try to figure out, okay, what to get to 5, I might need a 3, and a 2. So cosine of 3 pi over 12 plus a 2 pi over 12, because that would equal to 5 pi over 12, and then reduce these to pi fourths plus pi sixth. So then I can look at those, right? Because I know these ones, pi sixth and pi fourths. But might as well just convert it to a degrees, because you can add those easy, right? 45, so cosine of 45 plus 30. Right, so that was probably a lot easier than doing the fractions. Okay, so then how does Cosette arrange the date? Well, Cosette hangs out with her sister during the date because she doesn't like Sinbad, and she thinks their signs are different. And she makes Sinbad hang out with his brother. So just make sure when I take cosine of 45 on this side that I take sine of 45 on the other. Right? I take cosine comes first, cosine of 30, sine of 30. And cosine on these ones, make sure that cosine comes first. Okay, so cosine has to come first when we're doing cosine of an angle. When we're doing the sum or difference formula, cosine has to come first. Okay, so then we can figure these out. Cosine of 45, we did from last problem, right? It's root 2 over 2. Same with sine, root 2 over 2. We're subtracting in the middle. Cosine of 30, sine of 30. Cosine is root 3 over 2. And sine is 1/2. Now we're multiplying these. Now remember, so over here, 45 and 30 is both in the first quadrant, so our answers are going to be positive. I could have a 120 and 45. So I could have 120 minus 45, right? So there, I would have to look what quadrant I'm in for this sine and cosine of 120 and do the proper sign, or they're positive or negative. So just be cautious about that. So we get root 6 over 4. Ooh, that 6 looks ugly. Minus root 2 over 2. So then we get root 6 minus root 2 all over 4. And I didn't switch this to 4. Okay, so that is cosine of 75. And you'll notice that, hey, if we look at the last answer, that is 2 square root of 2 plus root 6, and then over 4. And if we look at this one, we have a negative in the middle, so it's like a little bit opposite, right? And that's they're not the same, right? So they're not equivalent, but they're very similar. You'll have a lot of answers that kind of look like this, because you'll have a lot of varies of 30 degrees and 45 degrees and 60 degrees. So a lot of your answers are going to look the same because we're using these same angles, right? Their exact value of those angles. So they're going to look the same, but they are different. Okay, let's do one more. Okay, here we're kind of going backwards. Going to use the actual identity and go backwards to find out what cosine or sine. But here, since we're only working on cosine, we know this is cosine, right? Because cosine comes first, and it's double, right? Cosine hangs out with her sister, so this is cosine. So we want to figure out what angles we're using. We're using 87 is our first angle, and then we're doing 93. And then our sine is always backwards on cosine, right? So this is actually going to be plus, so then we can actually add these. So we get 180, and cosine of 180 is negative 1. So the answer to this is negative 1. So on page 654, numbers 7, 11, and 15, you can practice those ones. Here, I'll do them for you. So cosine of 45, or 75. Well, we just did that, so you're done. Then number 11. Number 11 is looking at cosine of 7 pi 12ths. So again, what I would recommend here, instead of trying to figure out, oh, it's, 6, well, 3, probably 4 pi 12ths plus 3 pi 12ths. It's going to add up to 7 pi 12ths. And that reduces down to pi thirds. Oh, pi thirds, sorry. Pi thirds, which is a 60-degree angle. And this one's going to reduce to pi fourths. So 60 plus a 45. So the angle's probably going to be a 105. Which it is, because 7 pi over 12 times 180 over pi's are going to cancel. 12 reduces 180 by 15. 15 times 7 is 105. So really we're finding cosine of 105. Which is the same as cosine of 60 plus 45. Or you can use those two fractions, pi thirds and pi fourths. But it'll probably be easier for you to just convert it to degrees. Okay, so then Cosette is arranged to date again. Cosette hangs out with their sister. She doesn't think their signs are the same. She makes Sinbad hang out with his brother. Remember, cosine comes first, signs change. And so cosine of 60 is 1/2. That means sine is root 3 over 2. And then 45 is root 2 over 2. That's what's nice about root 2 over 2. For sine of 45 and cosine of 45, it's always root 2 over 2 for both of them. So these two are going to be the tricky ones, right? because you guys sometimes get these mixed up, is 1/2 and √3/2. Just remember, 60 degrees is a lot higher, so that means your y value is taller, right? And √3/2 is bigger than 1/2. So at 60 degrees, your y value is higher, and sine is your y value. And then it's backwards for 30 degrees. Okay, we can multiply these, we get √2/4, and subtract √6/4, so you notice that these all have the kind of the same answers. So cosine of 105 is equal to √2 minus √6. So that's the order of stuff is backwards on these ones. So there's our answer. Okay, so here you go on this. You're gonna go backwards. You're gonna find out what these angles, what our two angles are, and if they subtract or add based on our sine, and then is it sine or cosine based on, you know, what comes first. So whenever we have cosine and cosine first, that means that we are doing cosine function of a plus b, that in parentheses, and our two angles are 40 and 50 degrees. And you'll notice here that on the formulas, whatever angles first, after you, on your second term, so this is our first term, right? And then on our second term, that angle remains first, right? And on my examples that I did, as you can see up here, sometimes, well, I kept it the same, first angle first, first angle first. Sometimes I mix it up when we do the sine one. And I can show you that when we do the sine one. So here we go, we have 40 and 50, now we can literally add those, that's 90, and cosine of 90 is 0, right? So there, we're done.